Acquisition interviews, when startups get acquired, they go through interviews just like typical candidates do. And so one of the things to be able to do is prepare the same people repeatedly for interviews and see how consistent is their performance across different types of interview questions, and how does that actually map to how they perform in the real world. And then I also do the other side and help companies on their hiring process, do interview training, things like that. So what I'm going to talk about today is kind of a snippet of the interview training I provide. So some of it's going to go pretty quickly and not always go into a ton of detail in certain places, but I'll do the best I can with 45 minutes. But to get this out of the way, slides are online. You can go to go.gayle.com/interviewinglikeGoogle, and that'll hopefully, if I didn't do anything wrong, give you a link back to the slides. All right, so that's interviewing like Google. So first, just the overall philosophy of the hiring, of this kind of hiring process. One huge piece of it is just the kind of raw intelligence. Hire people who are smart, people who can, with the belief that smart people can, even if they don't know the technology you need them to know, they can learn it. They will make better decisions. They'll adapt to changes. They'll be able to adapt changes and learn new skills. That's a huge piece. I'd say the fundamental piece of this kind of hiring process is we want to hire people who are smart. Another big piece that at least companies should be thinking about, and what I'm going to talk about today, is keeping the candidate experience good. This is important, obviously, because it's a nice thing to do, to be nice to people, but also because if you interview somebody and they're awesome and they don't like you, they're not going to join your company. And even if you interview somebody and you don't like them and they don't like you, they're going to go write that nasty Medium article or that nasty Glassdoor post and post on Facebook or wherever about how awful that interview was. And they're going to tell all of their awesome friends to not interview with you. On top of all those things, this is a piece a lot of companies don't think about, the things that make candidates unhappy also make them perform worse in the interview generally. And so you're not even able to as effectively measure how good the candidate is if you're doing things that make them unhappy. So you'd be, think about that in a lot of different perspectives. Next thing that we're going to talk a lot about today in the next 45 minutes is signal. The point of interviews is signal, not is this answer in and of itself sufficient in the real world. And there's a difference between these two things. So, for example, where I'll see this go wrong is, you have a candidate who the interviewer asks some question, candidate solves, comes up with a solution, and is unable to progress towards the more optimal solution. And the interviewer says, it's okay, because this first solution, really, that's actually good enough in the real world. That's fine if they were actually saying, now I'm going to go copy and paste this code into our code base, which, by the way, is illegal. So it's not fine. But that would be reasonable to say this is good enough for the real world if you're actually going to use that exact thing in the real world. But what you're actually doing in the interview is you're trying to say, hey, do I think that this person will do good things in my company? And if them being unable to progress towards a more optimal solution is a signal that they have weak problem-solving skills and weak coding skills or a lack of knowledge in some area, that is sending you a negative signal about stuff that matters to you. So ultimately, you should not hire them, even though this solution might be good enough in some ways. So you really want to think, everything about the interview process, you really want to think about what is the signal you're getting from them. As a corollary to that, it is your responsibility to actually have this move. That's very weird. It just froze up. All right. I'll just end this slideshow if we can. Oh, no, awesome. Everything's frozen. All right. Yeah, it's actually. So as far as I can tell. this one up.
What's happening?
Ah, my computer's just frozen up completely.
That I might not be able to help with.
Yeah. Ah. Don't know why that would have fixed.
Maybe go line again.
That's a good start. All right. Hopefully that doesn't happen again. Okay. So as a corollary to the signal thing, it is your responsibility to have this freeze up. Okay. This is just freezing up on my side, I think. Okay, it is your responsibility to get that signal. So when you ask a question like, oh, tell me about a challenging project, and the candidate doesn't give a great answer to that, well, is that they didn't have a good challenge to say? Or they got nervous, they did this and that, they did not do a good job articulating the challenge? You want to push back and figure out what's going on there, drill in deeper, figure out what was the challenge there. Your goal, we often talk about things as simplification of saying, oh, we're looking for great candidates. Well, no, we're looking for people who will make great employees. If someone is bad at interviewing, but is actually a great employee, that's someone you want to hire. And a lot of people don't actually know the art of interviewing. I know this because I teach it all the time. And there is an art to it. There are things people can do to do better. The things that people can do to do better are the things that you as an interviewer want to kind of ignore. And then, close related to that, you're looking for good in the long run. Now, at least in most cases, you're looking for good in the long run. So not necessarily just is a person good, or not, is a person good in the first month, but people can learn things. Unless you really need, you're in dire straits and you need someone to do something right now, you're probably looking for more long term, and you want to know that and really keep that in mind in your hiring process. So, that said, there's a couple major types of questions. There's behavioral questions, there's knowledge questions, there are design questions, problem solving, kind of problem solving algorithm questions. Then there's the other interviews people sometimes do, like collaboration exercises. So something like pair programming would be an example of that. So out of interest of time, I'm just going to talk today about knowledge questions. I'll talk very briefly about that because that's just something that so many companies and so many interviewers just don't go about the right way. And then I'll spend most of the time today on the problem-solving algorithm kind of questions. So knowledge questions. So one company I was working with was hiring a bunch of people hiring new grads specifically. This was a team which did a mix of Java and SQL work. So they're hiring a bunch of new grads into the team. And so they're asking SQL questions to the new grads. So what kind of questions would you ask? What kind of SQL questions would you ask to new grads? This was kind of the thing I went back and forth with them about. They're asking a bunch of questions, basic questions, selects, joins, et cetera. And I pushed back really heavily on that. And the reason is that, look, these are new grads. You're not getting database experts here. You're getting new grads who may or may not have taken that one database as elective. So what sets apart the person who can do the selects and joins, the basic SQL stuff, and the person who doesn't is like 3 weeks in a class. Why do we care? Can you really, in this case, could this company really not afford to take and train somebody for a couple weeks in SQL? And in fact, to get up to speed with the stuff they're asking, selects, joins, et cetera, that wouldn't have even taken a couple weeks. And they can just learn that stuff. So all they effectively did in this hiring process was say, we're just going to reject anybody because we don't want to spend a week of time, or 2 weeks, 3 weeks of time having them learn something. That doesn't help their actual hiring standards at all. So the way that companies should think, the first thing companies should do is think about is, okay, we're doing SQL. What if a candidate doesn't know that? What if they don't? Is that an issue? And a lot of people jump to this immediate thing of, well, we're going to ask about SQL because we use SQL. We're going to ask about Java because we use Java. We're going to ask about C++ because we use C++. That in and of itself is not a sufficient explanation. A sufficient explanation is, look, we do a lot of machine learning. And this is a very hard thing to learn. It takes months or years to really develop expertise in here. And we really cannot afford to train somebody. That is a valid explanation. And that might work for some programming languages as well. where it really takes a lot of work to have someone learn that. You know, if you're certainly if you're working in assembly, yeah, you probably want to hire somebody who knows that. Not just because it would take a long time to learn it, but because a whole lot of people would hate it, and you know, you probably want to make sure the person actually likes what they're doing. But most teams that are doing Java don't need to actually hire for Java. Front end, mobile, maybe more, you need to hire more for that skill. So first thing you want to think about is if you're going down the road of knowledge questions, knowledge in some topic matters if it's hard to learn that thing. So it's, you know, take them a long time to learn about machine learning or whatever it is. Or if the fact that they lack it, given their background, is a red flag. So if somebody is a Java programmer and doesn't know how to make class A, you know, inherit from class B, you know, or basic stuff, sure, I can learn, I can teach them that thing, but gosh, what on earth is happening that they can't do basic stuff? So that's the kind of the major framework. Now, it should be either hard to learn, or it should be a red flag that they lack it given their background. So although I don't need the person to know Java, I don't need them to know this one specific thing, yes, they could learn it. They do claim to know Java, and yet they don't know some basics. My signal, my thing that I'm learning from this candidate is stuff that they use, they aren't really learning. Something's going very wrong here. So that's the way you think about knowledge. If you're going to go down this road, and for many, many, many teams, you don't need to. You just say, you know what, we don't really need the person to, we don't need to test their knowledge of programming languages. If you are going to do that, try to do it in a more open-ended way. So that'll allow people to get a lot more, you can go into a lot more depth, you can really look at, you know, expertise there. You can have them, even if they have a gap here, they can bring in their problem-solving skills elsewhere. Problem-solving skills and their other knowledge to kind of figure out, okay, how does garbage collection work? Well, I don't really know, but here's how I think it would work. I don't know how SQL, you know, implements indices, but here's how I think it might work, given what I do know. And that gets a lot more of the expertise. If you're doing a very shallow, basic test of stuff that people could learn pretty quickly, you should probably not be doing it at all. So my favorite ways of doing these sort of things are just, you know, asking them, how does garbage collection work? How do you think indices are implemented? How do you, you know, why would you use it? What are the pros and cons? Things that get into major discussions. One thing to be very aware of when you do this is if you're looking at expertise, not just the red flag test, but the true expertise, people can have gaps. Somebody who is working with C++ at Google might not work with particular aspects of the language because Google just says, we don't use these here. We won't let you use these here. So someone lacking that does not necessarily mean that they're not really that good at C++. It means they didn't have the exposure yet to learn this thing. So when you're looking for expertise, you're looking for, by and large, a good level of expertise, not complete 100% coverage. Because gaps can happen for very, very reasonable reasons. So ask yourself why there's a gap before assuming that's a really bad thing. And again, assess it more through open-ended kind of questions. Think about, you know, how long would it really take to learn it to that depth. All right. So that said, we're going to talk about problem solving now. So let's start off with a scenario. So you are doing a coding interview with somebody, and the candidate's pretty nervous, and they're making a lot of mistakes. They mess up some pretty obvious things like major syntactical errors. And you know, these are, you know, huge issues, much more so than typical candidate do. In 15 minutes in the interview, they calm down, and you know, they stop making these kind of major errors. Hire, based on this very limited set of information, hire or no hire? Where do you lean? Yeah, it's not. It shouldn't be, right? Ultimately, you're saying, okay, yes, maybe the ultimate code they wrote was bad, but what you're really trying to look at is, are they a good coder? Have they shown that they're a good coder? Well, okay, so when they're super nervous, they're not a good coder. Hopefully, your job isn't making them super nervous all the time. So, no, they're a good coder. Yeah, okay, part of their code sucked, but whatever. Look, when they are a good coder, and that's what we're looking at. We're looking at signal. Here's another example. So you ask the candidate a question, and they misunderstand it and go on the wrong track for about 10 minutes. You finally correct the issue, and then they, as a result, they basically had less time to tackle the problem you asked them, and so they don't complete the problem. Whose fault is this? How do you evaluate this as an interviewer? What do you do about the situation? Unclear? Yeah, so it could be that you didn't explain it properly. It could be that you actually did nothing wrong and they really just misunderstood it. Yeah. It doesn't matter, you're saying? What would you say? It doesn't matter?
They're supposed to work with you, and they didn't understand what you were telling them. It means that there's no match. So.
Yeah, so maybe it's a sign of a lack of match if they need to work with you and they didn't understand you.
Why did you let them be on the wrong track for 10 full minutes there?
Yeah, why, that's a really good question. Why'd you let them be on the wrong track for 10 minutes? So there's a lot of different things going on here, and there aren't necessarily exact answers. My thoughts here are, well, so 10 minutes is a long time to be on the wrong track. I'm going to, without a whole lot of information, I'm going to say that's probably the interviewer's fault. The interviewer really should have corrected that earlier on. Not necessarily, though. Sometimes the candidate can, understand the problem correctly, and then somehow their understanding, morphs. So there's that, but there's that issue to be aware of. Maybe it was maybe the interviewer really should have corrected that much earlier on. Probably, maybe not. Maybe the candidate was, maybe you didn't explain it well. Maybe the candidate wasn't paying attention when you asked the question. It is their fault. They were nervous and they weren't paying attention. That's why they misunderstood the problem. So, okay, that's their fault. But we go back to signal. Signal-wise, is that an issue? Is it a problem that the candidate, when they're nervous, blanked out? I don't know. I have a hard time saying, oh gosh, this is a huge error, even if, yes, it is their fault. I'd also say that even if they're on the wrong track for 10 minutes, maybe you got some signal and problem-solving skills. Yes, it wasn't on the right problem, but you got a signal and problem-solving skills anyway. Maybe not. Depends on the scenario. So ultimately, what all these things are coming back to is signal. What is this telling you about the candidate? I would, however, have in the back of my mind a thought of, this might be an unlucky day. It might also not be. It might be that every interview, this kind of thing happens. The candidate's making bad assumptions, they're making strange assumptions, they're not paying attention, they're misunderstanding things, and that is a really, really big problem. One of my friends right now is managing somebody who is constantly misunderstanding things. And it is a big problem to have an employee who's like that, and this person is getting managed out, as we might say. Because when someone's constantly misunderstanding stuff, you really can't effectively work with them. So what I would do here as interviewers, I would say, you know what, I'm going to disregard, in the sense of their score, I'm going to disregard the misunderstanding. But when I write my feedback, I'm going to make a little note there. This thing happened. This way, if every interviewer makes a similar kind of note, we can say, whoa, 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 this is not a one-off unlucky day. This is a trend. Okay, so what these kind of questions are about, these questions are supposed to be, these kind of algorithm questions, they're supposed to be problem-solving. They're supposed to be intellectually challenging. They are not supposed to be, how much does the candidate remember from their algorithms class? You want to do that as little as possible, actually. You want to see how effectively they can think, essentially how powerful is their brain. That is not how much have they memorized. Because, you can this helps hire people who are pretty smart. Smartness is a pretty good skill for an engineer to have. They are not supposed to be trick questions. They're not supposed to be brain teasers. The cool brain teasers that you heard, that's fun to kick around with your friends, that does not make it a good interview question. They are definitely not tests to see, ways for you to show how smart you are. And they're not supposed to be tests of your knowledge of the candidate's obscure knowledge either. So one thing to understand with these questions, one basic thing that goes wrong with a lot of interviewers and the way that a lot of interviewers think about it is they think, here's my question. I need to get the candidate to the finish line by the end of the interview. And so they give hint, hint, hint at the end because they're rushing, they only have 5 minutes left. Let me make sure the candidate finishes the whole problem. They ask questions that are far too easy. They reject the candidate solely because they didn't get to the finish line. This is not, we're going to come back to signal over and over and over again. We're looking at signal from the candidate. So if you got signal that, if you ask a very challenging problem and the candidate did a good job solving it and they've shown strong problem-solving skills, but they didn't get to the complete solution, that can still be a hire. Ultimately, they're showing strong problem-solving skills. That's what you're measuring. You don't need to worry yourself with saying, let me give 10 hints at the end to get them to complete the problem. Not if that, what we want to optimize for in the interview is signal and candidate experience. Do everything around the interview to focus on those things. How do you get a better signal? How do you get a better candidate experience? Getting to the finish line might hurt your ability. If you're giving them a ton of hints, it might actually hurt their ability to get a good signal. It might actually hurt the candidate experience. So I'm going to talk about a couple different parts of this, go into more details. One is what make good questions. Another piece is how, being nice and supportive. How do you create a good candidate experience? How do you coach candidates? There's a skill and there's a value in coaching candidates a little bit. And then evaluation. So ask some good questions. So there's a bunch of different pieces of questions. One thing is questions should be challenging. These are problem-solving questions. If the questions are easy, you're not really seeing how they solve questions. So imagine I said, okay, I want to test all of you in math. So I give everyone a math test. And I'm going to say that the bottom half of the group is bad at math. Okay. That may be okay to say, unless the test was really easy. What if all of my tests are, I give you 100 questions, and they're all single-digit arithmetic? And, not everyone's going to get 100. Sorry. Some of you are going to get, if I ask enough questions, some of you are going to get some questions wrong. It would be silly for me to say that you're bad at math because you got randomly one of those problems wrong, and now you're in the bottom half. And same thing happens here. If you ask questions that are too easy, candidates' performances get really clustered together, and someone doing poorly is like a minor little trip up. You want questions to be challenging. You want them to have to really think and kind of struggle through that problem. The other concern is that it sends a negative signal about the caliber of your company. And I've seen this actually happen a lot where companies will ask easy questions, and candidates take away from that easy questions equals low standards, equals bad engineers, bad teammates, I don't want to work there. And I've seen the opposite happen, where companies are able to distinguish themselves for having great engineering teams because their questions are challenging. So that's the other piece to think about. So you want questions to be challenging. That's one of the most important pieces. The questions should also be challenging, not because one piece is really hard, but because there's a lot of different pieces that take some problem-solving skills. If it's one hurdle, one piece of insight that's hard to get to, it becomes too random. A good rule of thumb here is if a single hint that you give a candidate would largely give away the problem, then it's too reliant on, it's too much of a single hurdle. As much as possible, those hurdles should be logically deducible. They should be, a piece of insight that you could logically deduce, not things that suddenly have to occur to you. So using 2 pointers to walk through a linked list, a fast pointer and a slow pointer to do a cycle thing, right? It's kind of a trick. Many of us have probably seen that before. We know it, we're familiar with it, but it's not really that logically, it's not logically that something that you would probably come up with on your own. It's very, very reliant on that. My rule of thumb here is if I'm noticing that some piece of insight that I want the candidate to get to, if I notice that I have a very hard time giving them some hints to get them there, that's usually a sign that, look, I can't logically lead them there. It's probably because that insight is really not that logically deducible in the first place. Now, there are, questions have trade-offs. And sometimes you might have that question that has so many great elements to it, but one of the pieces of insight is really an aha moment. That's not a deal-breaking issue. You just have to realize, look, getting there is not that indicative. It's not really getting you a straight signal on that candidate. So maybe you say, I'm going to just ignore this one piece of insight, and I'm going to very, very quickly give them the hint to get them over that hump. And then you largely mitigated the problem with that aha moment there. Questions should not be well known. This happens a lot. I've seen companies who will be like, when I'm working with them, be like, oh no, we're actually really good. We think our question database is fine. We basically just pulled all the questions from your book. Okay? So you're going to use the same source for questions that candidates are using. So basically you're just seeing how much have the candidates read my book. That's awesome for me. Please go on and do that. For you as a company, that's probably not something you want to do. So avoid questions that are well known. That means don't go pull all your interview questions off cracking the coding interview. I see interviewers who will go and say, what questions should I ask? This happens a lot of big companies. I don't know. So, they're a Lyft engineer and they go to the Lyft section on ClearCup or the Lyft section on Glassdoor and they pull questions from there. Well, then they're just looking at the same place that candidates will look, right? If you're a Lyft engineer and you want more interview questions, don't go look at Lyft. Go look at Amazon's questions. Go look at Google's questions. Any company other than Lyft, because you don't want to pull from the same place the candidates are pulling from. Where the patterns piece comes in is specifically on memoization and dynamic programming problems. These are really, really formulaic. One of the things I tell candidates is when you start preparing, go do like 10 of those questions. They're all very similar, they're very formulaic, and you'll do dramatically better. For you all as interviewers, don't ask these questions. They're really formulaic. The candidates who suck will continue to suck. The candidates who are just kind of okay with a bunch of practice can look significantly better than they used to be, which is a sign that it's probably not a great question in the first place. So I generally avoid those kind of questions. And if you have any doubt whether your interview question is well known or not, just ask the candidate, hey, if you've heard this question before, just let me know. A lot of candidates will not reveal that they've heard a problem before because they aren't really sure if they're supposed to. And so, when they're not really sure, they bias towards the thing that they think will get them an edge. Right? If you just say, hey, here, you set expectations that they're supposed to say that, oftentimes they will. So then with the knowledge piece, this is where a lot of engineers' objections to interviews come from. They're like, I never did a computer science degree, or I did it many, many years ago. I don't want to, this is ridiculous, I don't know this stuff anymore. And some of it comes from misunderstanding of the process, and some of it comes from companies screwing up what the process is supposed to be. These kind of questions are about someone's ability to solve a new problem. It's not about how much do you know about algorithms. You should almost never be asking anybody to implement breadth first search. That's not, you're looking at problem solving skills. That's not solving a problem, that's just coding skills. That may be an okay measure kind of coding skills. It's not a good measure of problem solving skills. You shouldn't generally be asking people questions that are either straight out of fundamental computer science or things even worse that are obscure knowledge. So Dijkstra's algorithm, that's obscure. My test for is it obscure is if somebody with a CS degree would forget it within a few years of college, then it's probably not a good question. So CS majors tend not to forget what a binary search tree is. They tend to not forget how to insert a node into it. They tend to remember what a graph is. They tend to remember what depth first search is. What they won't remember is how to balance trees. They won't remember how Dijkstra's algorithm works. They won't remember topological sort, things like that. So if you're looking at problem-solving skills, you don't want to be like, well, I want people to be smart and also have remembered this obscure knowledge that you actually don't really need to have. So keep the list of knowledge pretty simple. And what you really, really want to do is set expectations across the company. So there should be a list of stuff that's like, this is fair game knowledge, and this stuff is not. It's fair game to assume that somebody knows how to work with a binary search tree, knows how to insert, knows how to delete, actually delete's a little bit more complicated. They should know breadth first search, depth first search. They should not know these other topics. Communicate that to interviewers. Also, if possible, communicate that to candidates. So everybody's on the same, has the same expectations. That said, there's a complexity here where some interviewers will say, look, but this is stupid. I don't think we should even have to have, how often do we really use binary search trees in the real world anyway? I don't think we should have to even do this. And I actually kind of agree with that. I would actually love to tell you all, you know what? Your questions should be hard problems that involve only fundamentals. It should involve only strings, hash tables, and arrays. Right? Pretty much, you can ask lots of hard problems involving that, and this way the people who struggle on this stuff are struggling because of raw problem-solving skills and not because they didn't remember this one piece of knowledge. The only reason why I stopped from saying that is really that if I told people to do that, it would be so hard for them to come up with enough questions. So by allowing you to say, okay, as a trade-off, okay, binary search tree questions are okay, graph questions are okay, it allows you to access a whole lot more interview questions. If you're thinking the opposite, so with that said, so if you want to say, I don't think my candidates should have to know binary search trees, whatever, fantastic. By all means, don't ask those questions anymore. My favorite questions actually only involve like very, very, very basic stuff. So arrays, strings, hash tables, which is stuff that I would expect any programmer to know. If you're on the other side and you think, look, I'm on a team that does a lot of graph stuff. So we actually use Dijkstra's algorithm. We use Dijkstra's algorithm. We use these graph stuff. So I actually think we actually should be, these other more advanced topics are fair game. Also a fair point. However, I would say if that's the case, then it shouldn't be random. If you're thinking, look, I'm in the mapping team and we use Dijkstra's algorithm and we use topological sort and we use this and this, so I need to test these things, then do it. Do it explicitly. Do it with all of your candidates because you're saying we need this stuff. If you're unwilling to say all of my candidates will be tested on this, then what you're really saying is it doesn't matter that much to you. It's not that important whether or not the person knows this stuff. And if it's not that important, then just train people on it. If you really just use a couple graph theorems a bunch, graph algorithms a bunch, you don't necessarily need to test on it. You can train people on it, right? This goes back to the previous knowledge section. All the stuff I talked about with knowledge, with testing people on Java knowledge, whatever, that goes for these fundamentals too. You can train people on this stuff. The list of core data structure and algorithms, I train people on it in a matter of a couple days. It's not hard. If you value it, put it onto onboarding. A lot of interview issues could actually be fixed with onboarding. So think really hard about what you really need to have, what you really need for candidates, and what you don't. Generally speaking, advanced graph knowledge and advanced computer science knowledge is not important. There are exceptions, but in those exceptions, that's where you're hiring real deep algorithm experts in particular topics, and you're evaluating them specifically on that skill. So here's a question that I don't like. So this is a question that's implement RAND 7 from RAND 5. So you have a random number generator that returns a random number between 1 and 5. How do you use that to return a random number between 1 and 7? So the reason why I don't like this is that there's a particular thing you need to know, which is that there's no deterministic solution. You can have people spin their wheels for 30 minutes trying to solve this because they're thinking that they have to have a deterministic solution. So that means that they have to have some solution that will only call RAND 5 X number of times. It's physically impossible to do. As soon as you make candidates aware, hey, we actually can only do non-deterministic solutions, it becomes dramatically easier. This is one of those things where it's resting on one particular piece of insight, which makes it not a very good question. It's too reliant on that one thing. This is a question that I like. Given a list of people with each person's birth year and death year, find the year with the highest population. What I like about this question is that, most people can get a brute force algorithm very quickly. And then they can go implement that thing. And now I have my coding signal off the bat. We're 10 minutes into the interview and you've coded, and now I can spend the whole rest of my time working on just optimizations. But everyone gets something. Everyone has that win. No one does badly because they don't know graphs or anything like this. The only thing you need to know to do this is like arrays, maybe hash tables, maybe sorting, pretty basic stuff. But it has some challenge. It has a lot of insights. Here's another question I like. I actually talked about this in my earlier section for candidates. So given two strings, S and B, find all permutations of S within B. There's a brute force algorithm. The brute force algorithm is actually pretty obvious to come up with, pretty tricky to code. Then there's one optimization later that most people can get to, at least with some hints, most people can get to it. So pretty much everyone gets to a good algorithm they can then code pretty early on. But it's a challenging problem, but it's challenging not because it tests a bunch of knowledge. It's challenging because it's fundamentally a hard problem to solve. There's a lot of insights and pieces where I can evaluate someone's problem-solving skills. So I like this question for that reason. So that's questions. To do these questions, be nice. Be sort of like the goal of these questions is to challenge a candidate and to make them, the goal of the question is to have them think hard about something, which kind of means unless the candidate's awesome, they're going to be struggling. And a lot of candidates, that kind of makes them nervous to be struggling. So you really, really want to be nice and supportive. You want to say nice things to them. and this is kind of cheesy, but just little things like, great point, interesting observation, that's exactly right. So just little pieces of positive feedback like that can really affect somebody's mood during the interview. And the opposite is true too. If you give negative, little negative remarks, that can really affect how someone feels too. So be nice and be supportive. Coaching candidates, this is something else that's useful. So, there's hints, right? We talked about hints. Does giving a candidate a hint help you get a better signal or worse signal? Worse? Why?
You're kind of leading them on, so you don't know how much they would have done, how much your hint kind of guided them.
Yeah, exactly, right? Giving a hint helps them over some hurdle, and so you didn't get to see could they have climbed over that themselves. On the other hand, if there's 10 hurdles and they don't get past the first one, maybe that one hurdle is really, really hard for them for some reason, and they would have done awesome on the rest. So if you didn't give them that hint, they would just look like they suck, and actually they're really good. There's just one little thing that happened to be a deal breaker for them. So hints can be both. Hints can help you get better signal. It can also give you worse signal. The way I think about hints is there's a hurdle, there's a piece of insight I want the person to get to. Let me give the most vague, basic, simple hint at first to get them past that. Not tell them, try this approach, but just something very, very basic. And it might be, given in this array, where's the location of 13? It might be something that's like not saying, do this exact technique, try this thing, but it might be something very vague. I give increasingly specific hints so that they can get over the hurdle as independently as possible. Coaching, though, is something different. Coaching is things that are not specific to the problem. So it's all the stuff I would say in another presentation about, hey, here are good things to do better in interviews. So it's encouraging the candidate to talk out loud. It's giving them, encouraging them to come up with a example up on the whiteboard. It's saying, hey, that example is actually kind of a special case for this reason. Why don't we try this example? It's stuff that you can give to basically any problem. So whereas hints can give you better signal or worse signal, coaching things are things that pretty much always help your ability to get signal. They're just broad interview advice. Come up with examples, use large examples. Don't code yet, because I don't want to see you code. This isn't the piece I want you to code. It's all those kind of stuff. Coach freely. Take out the impact of interview prep as much as you can, because that's not something you actually want to practice. You actually want to test for. So coach freely. Give hints carefully. And then on evaluation, you're looking for signal, right? So it's not a simple binary thing of it must be correct, optimal, complete, ... It's signal. Did they show good problem-solving skills? Did they show good coding skills? And I'll talk about coding next, the coding piece of this. The way that I think about this is, how much did I feel like I needed to hold their hand through the whole problem? There are some people who, some people who I'm like, wow, I had to tell you every little piece of the problem. Even when I told you how to do something, you still struggle to understand it. I need to go into a lot more detail. Other people who were able to solve it completely independently. Other people where it was, they needed a little bit of help here and there, but able to make get a lot of their insights on their own. But this is relative to the difficulty problem. If I ask somebody the coding equivalent of what is 13 plus 7, almost any hint I give there, I'm going to be like, oh my god, I had to just walk you through everything. A much harder problem, a pretty strong hint, and being able to do it with just that would be still doing it larger independently. So it's relative to other problems, other candidates I've seen on that problem, but it's, how much do I have to help you with this problem, essentially. So you want to look at things like the difficulty of the problem, how much help you need to give them. You do not want to be influenced by confidence. Sometimes candidates who are more confident come off smarter, and you don't want to be influenced that way. Confidence is not something you actually want to hire for, not only because it's really not that relevant, but at least for the vast majority of roles, but also because the people who are confident in an interview or coming off as confident in an interview when they're on their best behavior might actually be, that might be their true behavior. It might also be that they've squished down their arrogance a little bit. So hiring for competence is not a very good thing. And then understand that early on, when you're evaluating, you are uncalibrated. You don't have a good source of comparison for that problem, and so you want to take that into account. Basically say, hey, your score isn't that accurate. The next piece of this is the coding piece. So problem-solving coding go hand in hand. The candidate solves a problem, then they go code it. A couple things to know here. I'm going to go through this pretty quickly, but what we're looking for is, can they translate the concept of code, and to some extent, their code quality. What is important to understand is it may not matter which algorithm they code. Because if I'm looking at coding signal, I can often evaluate that just as well on a brute force algorithm than on a more optimal algorithm. So that means that what I've realized with my interviews is, look, rather than what I used to do where I'd ask them a question, I have to give them, I have to have them work all the way through to the optimal answer before I have them code. And then I'm like constantly looking at the clock, I'm like, ooh, 20 minutes left, or I have them code now, can we still get this last optimization or do it? And I realized, I was like, wait. If I just want coding signal, who cares? Have them come up with a brute force, code that thing, get the coding thing out of the way. Now I've got the whole rest of my time to spend on optimizations, and I don't need to juggle my time. Makes it way easier. So you want to see them code. It doesn't have to be the optimal algorithm that they code. But it should ideally be an algorithm they came up with. Because one of the important pieces is, hey, they have this idea, can they break this down into steps? As opposed to having them code a known thing like merge sort, which isn't as useful. So when you code, tips, you don't have to have them code every last detail. If there's some little method in the algorithm or in the code that doesn't, they've done much harder bits of code, and it's just one little method to get the sum of an array. Writing a code to get the sum of an array is not very hard. If they've done harder things, you don't necessarily have to have them write that. Let them code in peace, basically. Let them use shorthand, particularly if they're on a whiteboard. Don't make them write hash map string comma integer, my hash map equals new hash map string. Like, that's going to take them forever. Let them use shorthand. If there's input checks and you want to see, can they think about input checks? So if there's a whole bunch of them, if it's just one, fine, they can write it. If there's like 10 input checks they need to do, that's not going to get you a great signal to have them write all that stuff. Focus on signal. How do you get signal if you still want to look at input checks? Ask them. What are the input checks? Don't worry about writing them, if you just talk out loud what they are. Gets you the same signal in a lot less time. So focus on that signal. Okay, so what you're looking for is the valuation comes down on the coding piece, comes down to basically seemingly compilable code. So that doesn't mean the code has to be completely compilable. If there's compilation errors that don't signal a problem with their fundamental coding skills, no worries. What I look for in their code is the people who don't suck. So, there's little issues with code where you're like, when I've done a lot of coding interviews, I'll see people who, one time they have basically flawless code, and the other time they have 2 or 3 little off by 1 errors, and the next time they're fine, and then they go back and forth. Those little errors are not that consistent across interview to interview. The person who's like an A+ coder is now an A- or B+. The people who write really, really bad code where you're like, what are you doing? That's consistent. Right? So look for people who are basically, hey, the code is basically pretty good. There aren't major issues. With suggestion, they could find the bugs when they got the time to do so. They could fix the issues. Maybe needed a bit of refactoring, but they were able to do that. You want to look for basic competence. You can't overly scrutinize such short pieces of code. It's just not a great code sample to do that with. I'll wrap up by talking just quickly about whiteboard versus computer. My short summary is there are pros and cons. You can be dogmatic about whiteboards versus laptops for our coding interviews. Look, there are pros and cons, and that's what I want people to understand. The value of whiteboards is that everybody's at kind of a level playing field. There isn't that candidate who gets into disadvantage because they haven't gotten access to good compilers or whatever. There aren't, the issues of you weren't able to get internet connection, this and that. Whiteboards keep everyone at a somewhat level playing field. It encourages more communication, and you get a better idea of their thought process. It's also, when you're up there at the whiteboard solving an algorithmically complex problem, it's kind of nice to not have to have the person totally switch gears into a totally different environment. The downside is that whiteboards can make some people nervous. Some people really, really hate whiteboards. Some people don't like laptops either, but the strength of hatred is much stronger for whiteboards. So laptops allow people to write a lot more code. Problem is, sometimes when people get the opportunity to write a lot more code, they write a whole lot more stuff that doesn't really matter. They start writing the main function, all these input checks, and this and that, and they get focused on compilation as fast as possible because you're hanging out over their screen awkwardly, like looking at what they're doing, and it's kind of weird. So look, there are pros and cons. What I'd say is this. Whiteboards, I feel, are generally better for algorithmically complex code. Laptops are generally better in interviews for stuff where there's a lot of code to write. So like a lot of mobile and front-end questions. Laptops are probably better for those. Or things that aren't algorithmically complex. But it really doesn't matter that much. So consider just letting the candidate choose. Or if you have a really strong preference on a particular problem, that's fine. But consider just letting the candidate choose. So why don't I just wrap up by just saying, remember that this is about signal. The whole interview process, the way you should think about your questions, the way you should, when you go into debriefs and you talk to interviewers and you hear an interviewer say something like, I don't know, the candidate, I lean no higher, the candidate really took a long time to code. That's when you should be able to push back and say, well, hold on, what's our signal here? Why did they take a long time to code? If they took a long time to code because they were really thoughtful and just analyzed what they're doing and they made sure that what they're doing was correct, the taking a long time to code is actually a good attribute. At least the reason why they took a long time to code. If they take a long time to code because they're really struggling to translate a concept into steps, that's a bad thing. If they take a long time to code because they're up at the whiteboard and their hand is broken, that is not a good or a bad thing, other than the fact that you really shouldn't have done that to the candidate in the first place. So focus on signal and candidate experience, but focus on signal. When you work with interviewers, when you talk to them about people are debriefing, stuff like that, get down to what the signal is that you got from the candidate, because that is ultimately what you want to be hiring on. Okay, I am happy to answer a few questions. Again, slides are, hopefully that link works. Anyone try it yet? Work, hopefully. If not, I'll get it working soon. Let me take a couple questions before heading outside, because I think there's probably another room, another person who wants this room. Yeah.
So one of the questions I have is, how can you gauge, and this is not so much about the interview, but how can you gauge a candidate's sort of hygiene? So I'm talking specifically about their tendency to test their code, to write tests, and comment their code.
Yeah. That's a great question. So how do you gauge a candidate's tendency to test and write and, yeah, be careful, things like that. So one of the things I say is, yes, those aren't good, like, whether or not the candidate tests their code after they write it is not particularly, I've not seen it be particularly indicative of anything other than interview skill. So I'd say don't be too biased by the candidate not testing their code after they write it in an interview situation. It just doesn't seem to map to anything. How you evaluate that is very, very difficult. But what I would say is, there's a lot of things we can't evaluate. Like work ethic can't be evaluated super well in interviews, and it's really important. What I'd say is, I'd flip that around and say, okay, do what you can maybe to evaluate it. You're probably not going to do a great job. I don't think ability to test code is necessarily a fundamental skill, separate from general problem-solving skills. And generally being kind of detail-oriented, writing code that's basically mostly correct. And I think a lot of it can also be trained on during onboarding. Train people how to write test cases, how to think about that kind of stuff, and not just rely on the interview process to predict a skill that is actually a trainable skill. Yeah.
So coming from like a candidate perspective, right from the beginning you were talking about correctness and signal. Right?
Mm-hmm.
You should focus on signal, but not so much correctness. But is that like I'm just trying to see if that's how like the top tier companies are they from whatever I've understood so far, it came across like they do really care about correctness.
Well, so correctness versus signal. So correctness isn't the opposite of signal, right? So correctness is an indication of signal. If somebody writes code and is wildly incorrect and they can't fix it, that is an the fact that they didn't notice that their code was incorrect, that it like the algorithm was fundamentally broken, that's signal. That's a signal issue. I'm learning they probably aren't able to think through their code very well. If something is incorrect because they wrote list.insert and in that language it's list.add, that is incorrect, but not in a way that is showing a negative signal about the candidate. That's a totally neutral thing that they wrote the wrong thing. So that's why I say it's not correctness in and of itself. It's, why is it correct? How is it correct and incorrect in what ways? Correctness of itself is not a filtering criteria. Yeah?
Yeah, how do you measure a candidate's sort of coachability and trainability? It's like, they did something wrong, you say, I can train that, but they don't want to be trained. They think
Yeah. So one thing, I think the technical interviews are actually a really good measure of a lot of the behavioral skills. A lot of companies think a lot about, let me go ask a lot of behavioral questions to figure out if they're a good fit at our company. And it's like, if you want to see if they're defensive, if you can teach them things, if they train things, look at that on a technical problem. That's actually how the candidate reacts to disagreements and suggestions when you're actually doing that is a better measure than asking, tell me about a time when somebody made a suggestion to you, when you're asking them, how much can you bullshit this question? Okay, so I'll go outside to answer any other questions. If you want to check out Cracking the Coding interview, the table should have been moved, so it's out there too.